So in the second chapter, we'll discuss about the different testing methods or different levels of testing, testing methods and different levels. Uh, so first we'll start with the two important methods of software testing, that is black box testing and white box testing. So these are very important type of uh, testing methods, black box and white box testing, that covers the different test cases for testing a particular software application. The approach for the black box testing is different and the white box testing is different. So there are different methods are there, different methods of white box testing and black box testing. Black box testing, it is also called as the functional testing, that checks the functionality of the software application. It is also called as functional testing. Black box testing is also called as a functional testing because it tests the functionality of the software application. And there are different types. The one is equivalence class partitioning, boundary value analysis, and cause effect graphing. These are the three important types of black box testing method: equivalence class partitioning, boundary value analysis, and cause effect graphing. One more type of the method is called as white box testing. White box testing is also called as structural testing. White box test method is also called as structural testing. So structural testing, the types are the coverage testing. So in that, statement coverage, branch and decision coverage, path coverage. So these are the different types of white box testing. So these different types of testing that covers the maximum errors, the maximum errors or defects in the software application. And at the last, we'll discuss about the difference, compare the difference between the white box and black box testing. So black box testing, that you already know, in black box testing we just focus on the inputs. We just focus on the input and the output of the software system. So this is very important, these two methods that may ask in your interview also. So whenever the software testing method comes, so these two types are very important. The basic types you should know, what is black box testing and white box testing. These are all very basic questions for your interview. Basic questions for the interview. So input. So whatever you give the input, like for example, we are not bothering about this code and all. We are not bothering about. We are not looking the internal details. Suppose if the input is you are providing 2 and 5, these are the two inputs that you are providing, and your particular module, it performs the operation of, like for example, multiplication. Okay, we don't know, we are not bothering about the code or logic of how the module it perform the multiplication. The output should be 10. We are just comparing the input and output. We are just comparing input and output of the software application. So in black box testing, we just focus on the input and output of the software system without bothering about the internal, the knowledge of the software program, without bothering about the internal knowledge of the software program. So that is black box testing. So the black box is an executable program that can be any software system that you want to test. Any software system that you want to test. So we'll discuss some examples. There are some general examples. Like for example, black box testing means like input an integer and it prints it. Means you are providing an one input and the code or this particular the module. Okay, this particular module what it does, it generates this program. It gives one output. Hmm? So you are providing an input. For example, 14. The input you are providing an input. If the input is that parameter if it is less than the 1024, it prints that value. Else it won't print. Okay. So this is simple. Just black box means this is the code. Whatever you are written, you are providing an input. Yes, 14. If the condition is true, then output it will print the value. So that is the black box testing. Suppose if you check the logic and all, the code, internal structure, if you analyze the step by step, then that is white box testing. That is white box testing. I hope you understood this executable program. So this is the executable program, and in this executable program, you are just you are not focusing, you are not analyzing any code here. You are just providing input and output. If you analyze the code and all, so that is white box testing. That is white box testing. So for example, this is a code. It takes the two numbers and the result. Okay. So in the black box testing means what? You are providing an input. Okay. Enter first number, second number. And what is the result? 25 for multiplication. Okay. Multiply the two numbers. Multiply two numbers. So this is the black box. And suppose for 5 into 5, if you are not getting 25, so you will check the some like code and all. You will analyze the code, and that is called as white box testing. Okay, we'll discuss that on the types and all. White box testing means we'll analyze the code. In this is a black box. You are providing an input and you are comparing with the output. So in your interview, if suppose if they ask a question, you should explain with the example. You should explain with the examples. So then only means they will come to know, okay, you understood the concept of testing. So that is some examples of black box testing. By applying the black box testing techniques, you derive a set of test cases that satisfy the following criteria. The test cases that reduce by a count that is greater than one the number of additional test cases that must be designed to achieve the reasonable testing. Means you need to reduce the test cases. For example, for a particular field, suppose if the age is a one field, and this age like for this particular age, the valid input is like from valid input is 19 to 60. Okay, 19 to 60. This is the valid input. Invalid means the 0 to 18 is invalid. 61 above is invalid. These are the two cases. Hmm. So here you need not write the test cases for all the input like 19, 20, 21, 22 up to 60. Okay, you need not write means for this test case. Test case means like for example for this one test case, if the input is 19, output is valid. Second test case, suppose if the input is 20, it is valid. So likewise, if you use to write for all the values, the number of test case will increase. Okay, so this is not the way. So that's why we use some black box testing techniques to reduce the number of test cases. Okay, because we know 19 to 60 means it is a valid inputs, means we have to check at least one input, like randomly we have to choose, like suppose 41. If you provide the 41 input, then it should take the, means it is a valid. And suppose if we provide 9, and the system should means that particular application should say it's invalid. So instead of testing all value input, it will take more time. Okay, so black box testing means the testing methods that reduce the test cases, that reduces the test cases. We will see that the different methods. Test cases that will tell you something about the presence or absence, the presence or the absence of the classes of errors. Classes means the group of errors, okay, in the range like 19 to 60. In this particular this is one class or one group. So if you if you test with one value, it will say that okay, it is valid, or presence of error or absence of error. So the different types of the black box testing methods are equivalence class partitioning, boundary value analysis, and cause effect graphing. So equivalence class partitioning, boundary value analysis, and cause effect graphing. So boundary value analysis, that is extension of this equivalence class partitioning. Equivalence class, actually you can also call as equivalence partitioning or equivalence class partitioning. It is a software test design technique software test design technique that involves the dividing the input values into a valid and invalid partitions. Okay, just now we discussed from the age group 19 to 60 are the valid, 0 to 18 are invalid, above 61 is invalid. Okay, so it partition the valid and invalid groups, valid and invalid groups by selecting a representative values, means one value. For example, in 19 to 60, suppose 42 is the representative value. Instead of checking all the values, we are checking with the only one representative value of in a group, representative value from the each partition as a test data. So equivalence partitioning means it is a software test design technique that involves dividing the input values into the valid and invalid partitions. Okay, valid and invalid partitions. So the example we'll discuss. One example is that, yes, this is the example. So what is the example? A text field that permits only the numerical characters, numerical values. Okay, it accepts only the numerical values. The length must be between the 6 to 8 characters or 8 character long, 8 numeric characters. Partition according to the requirement, it should be like 6 to 10 range, means 6, 7, 8, 9, 10. So these 5 numbers are the valid inputs. Okay, 11 above, this is invalid, this is also invalid. Okay, so while evaluating the equivalence class partition, values in all the partitions are equivalent. That's why 0 to 5 are the equivalent. 6 means like number of values. Equivalence class, so that it is also like equivalence class means like the digits. Okay, 13, 12, 11, 12, 13, 14. And these are valid class and invalid class. Valid and invalid. So that is equivalence class partitioning. Okay, it will divide the input values into valid and invalid partitions. Then boundary value analysis. In boundary value analysis, it is a software test design technique that involves the determination of boundaries for the input values and selecting the values that are at the boundaries and just inside or outside of the boundaries as a test data. So for example, in this case, so this one, these are the boundary values 6, 10. These are the boundary values. Okay, it is a software, it is also one of the test design technique that involves the determination of the boundaries, determination of the boundaries for the input values and selecting the values that are boundaries that are at the boundaries and just inside or outside of the boundaries. Even we can consider this also for invalid, we can consider these boundary values inside means this one, these two will come 6 and 10, and outside means these two, this one 5 and 11. Cause effect graphing. Cause effect means it is also one of the technique that involves identifying the cases, that is input conditions and effect. The cause and effect means because of the input, the effects, and producing a cause effect graph. We'll discuss with the example that generate the cases accordingly. So we'll discuss in detail the equivalence class partitioning. It is also called as equivalence partitioning is also called as equivalence class partitioning. Equivalence class partitioning. It can be applied at any levels of the testings, any levels of testing, and it often a good technique to use first. The idea behind this technique is to divide or partition, divide the input data. Okay, divide or partition a set of test conditions into the groups. Like groups means the valid or the invalid data, or the sets that can be considered the same. Okay, hence it is called as the equivalence partitioning. Equivalence partitioning is a testing technique where the input values are set into the classes. Like valid input class keeps all the valid inputs, and invalid means all the invalid inputs. Valid input class means it keeps all the valid inputs. Like in this case, 6 to 10 are the valid inputs. Invalid class means 0 to 5 and 11 to 14. Okay, invalid input classes. Then equivalent class partitioning that may be defined according to the following guidelines. If the input condition specifies a range, if it specifies a range, one valid and two invalid equivalence class are defined. Okay, one valid and, like for example here, one valid and two invalid class. One valid and two invalid classes are defined. Okay, if the input condition that specifies the range means, like for example, 19 age, 19 to 60 age, the range. So for that, this is the range, valid range. This is the valid, and the invalid means, for example, 0 to 18, then 60, 61 above. This is invalid. Invalid. Hmm. Then similar to if the input conditions requires a specific value, one valid and two invalid equivalence classes are defined. It is also same. If the input condition specifies a member of the set, member of the set, one valid and one invalid classes are defined. If the input condition is a boolean, if it is a boolean, one valid and one invalid classes are defined. Boolean means 1 or 0. So by applying these guidelines, w- we can derive the equivalence classes. So this is the example. So here you can see at the equivalence at the time of testing, the test 4 and test 12 are the valid input values. Test 4 and test 4 and 12 are the invalid input values here. This is 4, 12. These are the invalid values and 7 is the valid one. Okay, this one is valid. It is easy to test the input ranges 6 to 10, but harder to test the input that ranges from, if it is a large range, 2 to 600. So testing will be easy in the case of lesser test cases, but you should be very careful for the large, like for example, the range from 2 to 1000, 2 to 1000 means this range you have to test. So it will be means you have to use different other methods, boundary value analysis and all. Assuming if the valid input is 7, if the valid input is 7, that means you believe that the developer coded the correct valid range. Okay, so the range is what? 6 to 10. So in the 6 to 10 range, you are testing with a one input value that is 7. And if, for this particular input, if it is accepting, then it is a valid. It is a valid. So that is the to check the range. Suppose if the range is the size is very large, suppose 2 to 600 or 2 to 1000, then it will be difficult. You have to apply the other different approaches and your different methods, and you have to do the testing. Just one testing, one method, it is not possible. You have to apply. That's why different levels of testing, different methods you have to use. Then only you can cover the number of defects. The boundary value analysis. In boundary value analysis, it is widely recognized that the input values at the extreme ends of input domain that causes the more errors in the system. Like for example, in the 6 to 10 range, the boundary means what here? 5 and 7 boundary values. Boundary values that causes more errors in the system, the more application errors occurs at the boundaries of the input domain. So if it is a large range like uh, 19 to 60, then here 20, 18 means here this is one test case. Boundary value you have to take. Like for example, for 18, if you write a one test case of 18, this invalid input, then you have to show it is invalid, and for this boundary value it is a valid, invalid. Means you have to take the in boundary values. So that this is means after the equivalence class partitioning, you have to apply for the boundary value analysis also. The different you have to use different methods to cover the maximum defects. Boundary value analysis testing technique is used to identify the errors at the boundaries rather than finding those exist in the center of the input domain. So in the center means here from like 19 to in the 60 this range. Okay. So instead of checking the 40 value means that you covered in the equivalence class partitioning. So with the boundary value analysis method, you cover the boundary values. Boundary value. So boundary value analysis is a next part of the equivalence partitioning. So yeah, it is extension. We can say it is extension or next part of the equivalence class partitioning for designing the test cases where the test cases are selected at the edges of the equivalence class The boundary value analysis is the process of testing between the extreme ends or the boundaries between the partitions of input values, the boundaries between the partitions of the input values. So for this boundary value analysis, the process of testing between the extreme ends, as just now I told about extreme ends means from 19 to 60 range, the extreme ends are like here 59, 59, 61. These are the extreme end values. And here 20 and 18. Okay. So in this case, what are the valid? This 20 is valid, 59 is valid, and 89 and 61s are invalid. 81 and so this one, this is invalid, and here this is also 61, 61 also invalid. So like for example, for this range 19 to 20, 19 to 60, 19 to 60 range, for 19 to 60 range, we can write the 4 test cases for 18, 20, 59 and 61. Means if you provide input 18, then it should be invalid. For 20, it is valid. Boundary value, we are checking the boundary values. 59, just cross check, means the developer has done the coding or the coding of the application. Your job is to test whether for particular input your software is working or not. For 59, it should give valid, and for 61, invalid. Okay. So in this way, you have to cover the invalid or valid values. So example, so these extreme ends like start, end, or lower, upper, maximum, minimum, just inside, just outside values are called boundary values, like 18, 20, 59, 61. These are all called boundary value analysis testing. Suppose you have to you have a very important tool at the office that accepts a valid username and password field to work on the tool, and it accepts a minimum 8 characters and maximum 12 characters. It accepts the minimum 8 and maximum range 8 to 12, minimum 8 and maximum 12 characters. So the valid range is 8 to 12 and invalid range is less or less than 7, 13 or more than 13. So for boundary value analysis, so this is the valid 8 to 12 is the valid partition, 8 to 12. is the valid. Invalid means less than 8, like 7. So this is invalid. 13 is also invalid. Hmm? More than 12 invalid partition. So write the test cases for valid partition value and invalid partition value and exact boundary values. So test case 1 is that consider the password length less than 8. One test case is that to provide a password of the length less than 8 means it is invalid. It is a invalid. Then consider a password length exactly 8 means it is valid. Means you are providing a 8 uh, 8 characters. Then consider the length between 9 and 11. So that is also valid. Consider the length exactly 12. That is also working, invalid. And suppose if it is more than 12, then it is invalid. That is invalid. Okay. So this is how we rate the test cases. Means for each test case, we'll find out whether means it should work. Like whether 5 test cases are there, and the tester will provide like a less than 8 characters. Less than means like suppose 6 character. Then it is invalid. It should the expected output is invalid, and it should not accept. Okay. In testing, we'll compare the expected and actual. Expected and actual, it should match. For this test case, for this it is invalid. Expected is, what is the expected? Less than, our condition is that 8 to 12 are valid characters. 8 to 12 the length. If we provide the less than 8, what is expected? It's a invalid. Okay, it should not accept, invalid. And when the tester tests the application, so the whatever the result he gets, actual, both it should be equal, expected and actual. Then only we can say the test case is passed. The test case is passed or failed. Suppose if for less than 8, if it is accepting, if the value does not match, then the test case is failed. The test case is failed. Okay, so this is all about the equivalence class partitioning and boundary value techniques of the black box testing method. Okay, 6 to 7, this is valid and this is invalid. Okay, invalid and valid groups. So that is equivalence class partitioning. Means like you no need to read the test cases for all the inputs. Any one, like the out of this value 6 to 10, you are checking at least one valid input. Equivalence class partitioning, then boundary value analysis. So the test cases that are not covering, so in equivalence class partitioning, we'll cover through boundary value analysis. Boundary value analysis, it is the extension. It is the extension of the equivalence class partitioning. Here we will consider the boundary values. Boundary values. For example, here for a password field, 8 to 12 characters. So 8 to 12 means here the minimum is 8, maximum is 12 characters. So what is the valid means? This is a boundary value we have to take, only boundary value. 8, 12, inner boundary, outer boundary means like 7, and here 13, 12, 13. Okay. So valid and invalid partitions we have to consider. Then cause effect grouping. Cause and effect, as the name indicates, a cause stands for the separate input conditions that fetches about the internal change in the system. and effect represent the output condition. Means because of the input, the output. Like for example, uh, so here these are the different input conditions: cause 1, cause 2, cause 3, cause 4. Means the different conditions. Because of this condition, the output. Okay, so this is a cause effect flow diagram. Like for example, because of the this is the notation how we represent. Because of the cause 1, cause means the input, some condition, input condition. Okay, cause 1 means it's a condition. Because of this condition, the effect. Because of this condition, this is the effect. It's positive, negative conditions we will check. Similar to that, here the three causes. Because of these three condition, this is the output. So cause effect means based upon the input, the output will affect it. Means we have to. It is like a similar to the valid and invalid, but here we will consider the different conditions. Here we consider three, here two conditions, and because of that condition, the affected output. So for example, here the some cause effect example is there for the cause effect. The print message is a software that reads the two characters, and depending on their values, message must be printed. Means it reads the two characters. Reads the two characters means inputs two characters, and depending on that value, message must be printed. So here the first character is A or a B. The second character must be a digit. Okay, second character must be a digit. So the first character is an A or B, and the second character is a digit. The file must be updated. Like for example, if the input is like for example A and some digit, with this input the file is updated. Means this is a cause and effect. Because of this input, the, the output, this is expected output, so we'll compare this with the actual output. So this is the cause effect. Or suppose if the first character is B and some digit, the file is updated. Okay, these are with respect to the condition. Print a message. The print message is a software that reads two characters, and depending on their value, message must be printed. What is the output here? Message must be printed or updated. Means cause means with respect to the input, the output will affect it. So these are the different types of black box testing. Different types of black box testing, that is equivalence class partitioning, then boundary value analysis. You have to remember for your exam or even interview also. Equivalence class partitioning, then boundary value analysis. We consider the boundary values of the valid and invalid classes, boundary values, and cause effect method. So means for testing any application, we have to consider all these different methods, for the to cover the defects in an application. So let us discuss the advantage, disadvantage of the black box testing. It is well suited and efficient for the large code segments. Well suited means here we are not bothering about the codes and all. We are just focusing on input and output. Code access is not required. We are not accessing the code, and that is the advantage. Even the non-technical people or the one who have the basic knowledge of the programming, that he can go for the black box testing, and clearly separate the user perspective from the developer perspective through the visible defined rules, user's perspective as per the user requirements. and large number of moderately skilled testers can test the application with no knowledge of programming or implementation or operating system. So the one who can test the software, skilled software tester, the if suppose if he is having some basic knowledge, he can he can go for the black box testing with no knowledge of implementation or programming knowledge, because here he is not going through the details of the code and all, just providing the input and output. Suppose if it is a multiplication 2 into 5, and the output should be 10. So the drawbacks are the limited coverage. Limited coverage means uh, we are not the since only a selected number of test scenarios is actually performed. Means based upon the input and output, we are not checking all the details. Okay, so based upon the input and output, the few test scenarios are actually performed. Inefficient testing due to the fact that tester only has limited knowledge about the application. Limited knowledge about the application. Because the developer, because suppose if you know the coding and all, so he can the you can again you can test with the different scenarios. So that is inefficient testing. Blind coverage, since the tester cannot target a specific code segment or error prone areas. Then the test case are difficult to design. Yeah, even because if suppose if he is having a knowledge of programming, so he can write some other different test cases. So the test cases are difficult to design. So that's why the company they prefer the one who is having a programming knowledge, the one who is a programming knowledge. So nowadays that is agile team. Agile team means the the members they work as a tester or as a developer also. Okay, so that's why this scenario is different nowadays. Nowadays like the one who has to know all the knowledge concepts like developing and testing methodologies and all. Next we will discuss about the one more testing method, that is a white box testing. So white box testing, it is also known as a clear box testing, the different names, open box testing and glass box testing. Okay, as the transparent box testing or code based testing or structural testing. These are all different names. These are all the different names of this testing. Why this clear box means what? You can see the code. That's why the clear box. Open box. Open means again you can see the code in a module. Glass box. Glass, as the name indicates, glass means again you can see the code. So just you can with respect to the name, black box means you can't see the module code and all. Transparent testing, code based testing, structural testing. So these are all different different names of the testing methods. That is white box testing. So this white box testing is a method in which internal structure, design, implementation of the item being known tested is known to the tester. Means the internal structure of the particular module. For example, just the concept like what white box testing means. Suppose you are like these are the some modules: login, registration, then one more module like payment transfer, Suppose these are the payment, payment transfer, then payment transfer, then account details, account balance. Okay, okay, account balance. So these are four modules, and in white box testing means that we are like the unit testing. Unit testing is also one of the type of unit testing is also one of the type of white box testing method. So in unit testing, integration testing, these are all the type of white box unit testing. So in unit testing, what we do, we individually we test the modules. Individually, we test the modules like login module, registration module, payment transfer, account. Individually, we'll test, will analyze the code, will analyze the logic. Okay, analyze the code and the logic of these modules. Code coverage. Code coverage means the line by line code path coverage. We'll analyze the line by line code of each modules. So that is, these are the different modules, and that the testing of independent module is called as unit testing. Unit testing is the method. Then integration testing means, like, suppose by integrating these two modules, login and registration, means it should work. Like, suppose if you are registered successfully, then if you are registered successfully means the you can be able to log in. Okay, after once the registration is confirmed, you should be able to log in. Means these two modules should be interconnect, and it should, like, integration means it should work properly. Once you are registered, then you can able to log in, and those who are not registered, they should not able to log into the particular module or particular web page. So these are all like the integration. Integration means the integration of these two modules. So that is also unit testing. So I hope this concept is clear. White box testing. White box testing means we'll analyze the code. So white box testing is like a work of a mechanic, a mechanic who examines the engine to see why the car is not moving. Okay, so this is just a general example. Okay, suppose if your car or if your vehicle is not working, okay, vehicle is not working, and the mechanic, he will just like, generally he will change the oil, or he will check the engine parts and all. Okay, so internal details, he will analyze, he will step by step, he will go through all the parts of the vehicle. So that is white box testing. The tester needs to have a look inside the source code, inside the source code, and find out the which unit or the chunk of the code is behaving inappropriately, which source code or the which line or which condition in the code which it is behaving inappropriately. So that is the job of a tester. So for the so here you are analyzing the code. Analyzing the source code means the programming knowledge is required. Programming knowledge is required for the white box testing. Programming knowledge is required for the white box testing. Using white box testing methods, you can derive test cases that guarantee that all the independent paths within a module have been exercised at least once. The independent path in a code, independent path in the code, independent path within a module that exercise at least once. Exercise all the logical decisions, the conditions on the true or false side. Execute all the loops, execute all the loops at their boundaries within the operational bounds, and exercise the internal the data structure to ensure their validity. So white box testing means you are covering all the paths, the loops, conditions, and all the logic. So this is the how you can explain graphically the white box testing. So white box testing means you are looking at the internal details, the conditions, the logic, the loops. Okay, so it's very different than the white black box testing. So in the black box testing, just you have to focus on the input and output, input and output. So how about the black box? Yeah, you see the internal details are not visible. Internal, the details are not visible. Here you're just focusing on the input and output. So it's a completely opposite, input and output. That is a black box. Why and when the white box testing? When to use white box testing? White box testing is mainly used for detecting the logical errors in the program code. Logical errors. It is used for debugging a code, finding the random typographical errors, uncovering some incorrect programming assumptions. White box testing is done at the low level design and implementable code. It can be applied at all the levels of the system development, especially uh, the unit testing, system testing, integration, all the levels. So this is called as levels of testing. What are the levels of testing means? The levels of testings are the unit testing, integration testing, unit integration, and we'll study about these different levels: unit testing, integration testing, and system testing. So these are the different levels of testings, different levels of testing. So white box testing can be used for the other development artifacts like requirement analysis, designing, and test cases. White box testing, white box testing techniques, the different type like in the black box, equivalence class partitioning, boundary value analysis, cause effect cropping. Okay, equivalence class partitioning, equivalence class partitioning. Then what are the others? Boundary value analysis, boundary value analysis. Then cause effect grouping, cause effect, cause effect grouping, graph. So similar to that, in white box testing, what are the different techniques? Statement coverage, branch and decision coverage, and path coverage. Statement coverage, that techniques aimed at exercising all programming statements. It covers the all programming statements with minimal tests. Branch and decision coverage, as the name indicate, branch, the branches. Okay, if the condition is true, it jumps to the particular statement. Condition false, then it will jump to the other statement. Branch or some other, okay, part of the code. Then decision coverage. An example of a tool that handles the branch coverage testing, the different C plus Java applications. Path coverage, we'll discuss some example for all these: branch coverage, decision coverage, path coverage. That correspond The path coverage means all possible paths, which means that each statement and branch is covered. Means every path should be covered. the different paths in a flow of the statements. So statement coverage, this is for the statement coverage, branch and decision coverage, and path coverage. Statement coverage, branch and decision, and path coverage. These are the main three types of white box testing methods. So in statement coverage, the statement coverage is a white box testing technique which involves the execution of all the statements at least once. Statements, it executes the statement at least once in the source code. The statement coverage, we can identify the statements executed where the code is not executed because of the blockage. We'll see with the example. The statement coverage that covers only the true conditions. It covers only the true conditions. When the condition is true, it will jump to the that particular statement. Means it won't execute the false statement. Okay, because of this, it won't cover some of the statements. So that is a drawback of this statement coverage. The statement coverage only it covers what? True conditions. It covers only the true conditions. It covers only the true conditions. The main drawback of this technique is that we cannot test the false conditions. We cannot test the false conditions in the statement coverage. Statement means here we can see one example. So these are the two numbers A and B. You are reading A and B. If A is greater than B, print A. Print A is greater than B. Okay. If condition is true, if this is true, then you are printing A is greater than B. And if you are coming here, you are not testing here. You are not testing the false statement. Okay. You are not testing the false statement. So here out of these seven statement for this A and B, if A is 5, if this is 5 and if it is 2, 5 greater than 2, so condition is true. So you are executing this statement A is greater than 5. So you are not testing this else part. So you are testing only the five statement out of the 7. So that is 71% of the statements you are covering in this case. So statement coverage means what? It covers only the true conditions. It covers only the true conditions. The drawback of this technique is that we cannot test for the false conditions in it. So the statement coverage is the number of statement executed. The number of statement executed. So in our case, it was 5 and divided by the total number of statements. Total number of statement is 7 in that particular exam. So here you will get around 71 percentage. Means we are not covering all the so to cover all the statements again we go for the one more white box testing technique. Okay, so this is about the statement coverage. Statement coverage means it covers the true conditions. Then one more type is branch or decision coverage. Branch or decision coverage. Branch coverage is also known as the decision coverage. Branch coverage is also known as the decision coverage or all edge coverage. All edge coverage. It covers both the true and false conditions. It covers both true and false conditions, unlikely the statement coverage. A branch is the outcome of a decision. So branch coverage simply measures which decision outcomes have been tested. This sounds great because it takes a more in-depth view of the source code than simple statement coverage. Okay, it goes in depth. In depth means what? In the statement coverage, it covers only the true conditions, but Branch decision coverage, we are covering both true and false. Both the conditions we are testing. Means we are rating the test cases for both. Okay, so like you can see the example, read x, read y. If x is greater than y, then this is the statement, and here 100%, here else condition is not there here in this case, but here you have to write the different test cases. Okay, if the condition x is greater than y, you are covering all the statements. This is the test case 1. What is the test case 1? If it is 10, if it is 5, 10 greater than 5, condition is true, condition is true, it print this message. Okay, here is 100% decision coverage, but for false condition you have to write one more test case. One more test case. What is that? Test case 2, x is equal to 2, y is equal to 10. So in this way you have to cover 100% all the statements. 100% all the statement coverage. So that is the statement coverage, branch or decision. First one is the statement coverage, branch coverage, branch or decision coverage. We will write the test cases for both positive and means like positive condition, negative for conditions for both true and false conditions, and we will cover all the 100% statements. Then in the path coverage, the basis path method, the path enables the test case designer to derive a logical complexity measure of procedural design and use this measure as a guide for defining a basis set of execution paths. Path coverage means like for example here, suppose if the condition A is true, then go for this function. Once this is completed, function 2, then again check the condition of A, concurrent statements, then function F3. So this is the path how these are the different possibles. If condition A, F1, F12, F2, okay, then again A, F, this path F3, F4, this is the one possible way. Then the second A, if condition is, if it is true, if this one means we have to cover all the possible paths. We have to cover all the possible paths. So that is the path coverage based upon the true condition, because A is a condition. Based upon the true condition and false condition, we need to cover like if A is true or false. Based upon this, we have only two possibles. Based upon this, we need to cover all the possible paths. So that is path coverage. So totally in white box testing, how many methods are there? Statement coverage, then second one is branch coverage or decision coverage, then third one is path coverage. So with these three methods, okay, we can do the white box testing. Okay, white box testing means we will cover all the paths. So I hope you understood all the concepts, the black box testing, white box testing, these unit testing, system testing, integration testing. We will do such type of testing that is called as static testing. In dynamic testing, at the later stage of the development life cycle. This is early stages, and here code is not executed. Early stages, and it is later stage. Means it's a verification testing. Static is a verification testing. Okay. Okay. This is last point. Is the last point. Static testing is more statement coverage than the dynamic testing. Dynamic testing is less statement stage. It covers the limited area. Means it covers the area of code. Means it go through the, it runs the code and all. Will, okay. In dynamic testing, we run the code and we'll test the errors, or we find the defects. And in static, it is done before the code deployment. It is done during the code deployment. It is performed in verification stage, and it is in the validation stage. Static testing, this is a type of testing is done without the execution of the code, and here it's execution dynamic testing. Static testing gives the assessment of the code as well as document. So it gives the bottlenecks of the software system. Here where in dynamic testing where we are testing at the different levels, where like unit testing, integration testing, and the system testing. So it covers the maximum errors. Static testing, as per the checklist is prepared, that is inspection. A checklist, as per the checklist will verify whether all the other the verification is inspection process is completed or not. So here the test cases are executed. We'll compare the output, actual and expected outcome will compare in the dynamic testing. So here the techniques walk through code review and all. Here it involves the functional and non-functional testing. Will non-functional testing like performance testing. Will compare the test the performance, security, and all. So that comes in the dynamic testings. So if you consider one example for the software application like online shopping cart, and what are the points we'll cover in the static, like review the design documents, requirement document that initially, and check the GUI of the application, checking the database structure of the application manually. Okay, so these are some, just one example for particular application. What are the points that cover in the static testing technique? And in dynamic testing, the functionality of means validating. We are validating the functionality of different pages, checking the checkout process and payment method, validating. Okay, then testing the interface between the different pages, interface between the, is there any, like, because we are doing unit testing, integration between the different modules and all. So for this particular online shopping cart, we can consider these some category, like what are the static testing technique, what are the dynamic testing technique. So for any application, it is depend upon the organization, or it is depend upon the team, that they will decide which type of testing they can refer, which type of testing they can refer for the any software applications. uh, so it is up to the team or up to the organization that they will prepare for the methods. There are so many other methods are there. So what are the other methods, like this verification and validation, also the type of testing, black box, white box testing, static, dynamic testing. Okay, so these are all we covered. Equivalence class partitioning, then other data testing, state testing, then white box testing we cover data coverage, code coverage. Okay, so almost the even the second unit is also we complete by the next class. So you should know, like what are the other different techniques, and what are their when we use such type of testing techniques. And it is depend upon the organization. They can use all the testing techniques to cover the maximum errors, to cover the maximum errors. Equivalence class testing means it is divide the input value into equal parts, and in that we'll check the valid and invalid inputs, right? So that is uh, equivalence class testing, equivalence class partitioning. Okay, we divide the value into valid and invalid inputs. And in continuation with that, the boundary value analysis. So boundary value analysis means we'll consider the boundary values of the equivalence class. Okay, instead of, suppose if there are 8 to 12, 8 to 12 characters are the valid, so we'll test it with the boundary values like 8 minus 1, 8 plus 1. Here the maximum is 12. So 12 minus 1, 12 plus 1. We'll check with the boundary values. So today we'll discuss about the data testing and state testing. So that is, it is also a type of equivalence class partitioning. Uh, so the simplest view of the software, that is divided in divided its word into two parts. The software means it's a data or the program. The data or program. So the data input. So data testing means the whatever the value, the input you provide. So that is a data testing. Okay, we'll discuss with some examples. So the data is the keyboard input, mouse click, the disk files, printouts. Okay, so these are all the input what we provide, and after processing we'll get the output. That output we compare with our actual outputs. Okay, actual and expected outputs. So the program is executable. Program means the executable flow, transition, or logic and computations. So software means it consists of two parts. The one is the data part, another is the program. So data means the whatever we provide the input through keyboard or mouse click. Uh, okay, so these are all some the data we are providing. Like for example, uh, to provide the values, we use the mouse cursor, and we'll select the particular field, and through keyboard we provide some data. Okay, so with the software, it processes the data and it produces the output, and that is we compare with the expected output. Program is logic, transition, execution flow, computations. So a common approach to software testing is to divide up the test work along with the same lines. When you perform the software testing on the data, you are checking that information the user inputs, the results that he receives, and any interim results, the internal to the software, are handled correctly. So the examples of the data are like, for example, the word that you type in the word processor, the numbers that you enter in the spreadsheets, the number of shots you have remaining in your space game, the picture that is printed by your photo software. Okay, suppose if you are in the photo, you are with a mouse, you are printing, you are doing some picture, then backup files stored on your floppy. These are all that consider as a data. But in boundary conditions means it is one of the type of the equivalence class partitioning. Okay, the data testing is one of the type of the equivalence class partitioning. So equivalence class means, like for example, here we divide the data into some valid, invalid classes, right? Valid and invalid classes. So The data testing, it is also the extension of the boundary value analysis. Boundary value, that is also the type of the black box testing. Equivalence class partitioning. Equivalence means it divides the total raw data into the valid and invalid data. Okay. So suppose this is valid, this is invalid data, this is invalid data. The boundary conditions are those situations at the edge of the planned operational limits of the software. The boundary values. So this is suppose valid data means this is the boundary values. The boundary conditions. This is the boundary conditions. Okay. Suppose for example here, like just now we discussed one example, 8 to 12 characters. For a password field, there should be 8 to 12 characters. So these are some characteristics of the data types. What are the characteristics? Like the first, last, min max, like the 7, 9, 11, 13. So these are the like valid. The 9 and 11 are the valid input conditions. 7 and 13 are the invalid conditions. So these are all the type of the characteristics of the these types: numeric data type, character data type, position, quantity, speed, location, size. These are the different type of the data that we specify for testing the software applications. So just consider this example. The example, okay, a software a software boundary is much like the edge of a cliff. So edge of a cliff means it's like it is a vertical the mass rock. So this is a rock uh, that it is a vertical height. Okay, so it is edge. So the best way to describe the boundary condition testing is if you can safely and confidently walk along with the edge of this cliff, okay, without falling off, then you can almost certainly walk in the middle of the field. Okay, this is just a general example that given in your textbook. So from that I have taken, okay, the best example so that you can understand means if he can walk safely and confidently along at the edge of this wall or the cliff, okay, without falling off, so you can almost certainly walk in the middle of the field. So if a software can operate on the edge of its capability, it will almost certainly operate well under the normal conditions. Okay, if the software is working properly with the boundary conditions, software is working with the boundary conditions, then definitely it will work with the values that are specified in the middle. For example, okay, so this is the boundary values. Uh, suppose if the 1 to 6 is the field that accepts the input, the field that accepts the input 1 to 6. So here, so this is the 1 minimum and 6. So what is the boundary value here? Outer boundary is 7 and 5. Here 2 and 0. Okay. So these are the boundary means if the software is working for the boundary values, if the software can operate on the edges of its capability, it will almost certainly operate well under the normal conditions. Normal conditions means, like for example, if the input is 3, 4, 5. Okay, or if the suppose if the valid input size is large, for example 0 to 256. Okay, if the 0 to 256, then in such cases you need to check the boundary values. Then when presented with the boundary conditions, when presented with the boundary condition, always test with the valid test just inside the boundary and test the last possible valid data and test the invalid data just outside the boundary. Okay, here the outside the boundary means 0 and 7, in this case 1 to 6. Okay, so yeah, this already we covered in the boundary value analysis. So the data testing, it is also a type of the means data testing means we have to consider in terms of the equivalence class and the boundary value analysis. Okay, so these are some examples that I have taken from the textbooks. If want to 255 characters, if the field that allows 1 to 250, so try entering the 1 and 255 characters as a valid partitions. You might also try for the boundary values 254 and as a valid choice. Okay, 254 means the boundary value of the, because it is immediately next to the 255. Okay, so 0 to 256 are the invalid partitions. So here the minimum value, boundary value. Okay, and here 256. So there you can take one more example for 9-digit zip code or pin code consider. So the smallest value is this and the maximum value is this one. So in this way we need to do the testing, that is called the data testing. The data is very important for any, like for the applications. So if you are testing the flight simulator, so try flying right at the ground level or at the maximum allowed height for your plane. Okay, so this is how we do the testing of with the data. There is one more example that consider a paint application, a Windows Paint application, where suppose if the default values of width and height of the text field. Suppose if you check the image property and if you want to verify the width and height of the that particular image attributes. Okay, suppose it has some default values, and if you delete those default values, okay, accidentally or purposely, if you delete them and the fields are blank, then it clicks OK. So what happens? You will get an error. So, okay, you will get an error. So that is called as the data testing. Suppose if it is okay with these blank values, then it's a failure of the application. It is a failure of the application. So you need to do the data testing. So that is data testing is a also the type of the black box testing. Okay, black box testing. Black box testing consists of equivalence class partitioning, boundary value analysis. Okay, so it comes under equivalence class type, black box testing method. So in the black box, which one? Equivalence class testing. Then in equivalence class testing, you can see the data testing and state testing. One more testing method is the state testing method. Okay, so state testing, so simple state, it specifies the state of the operation or the transaction. So a software tester that must test a program's state and the transition between them. Program state, like consider one example. You have been testing the data, the number, words, input and output of the software. So that is data testing. The other side of the software testing is to verify the program's logic flow through its various states. The program's logic flow through the various states. Okay, so here a software state is a condition A software state is a condition or the mode that the software is currently in. Like for example, when you for this paint application, when you select this particular tool, okay, pencil, then the cursor will change its state from that cursor to the this pencil cursor. Okay, the initially it is mouse. When you click on this button, pencil tool, so it will change to the pencil, the icon. So that is a one state. And when you hold that pencil and if you write, okay, something on the paint, then the state will change. Okay, so that is pencil drawing state. So this is called as the state testing. States, you have to verify the program's logical flow through its various states. So a software state is a condition or the mode that the software is currently in. And again, if you consider same example, if you change the it with the airbrush tool, okay, and the previously the state was like pencil tool. Suppose if you again if you change with the if you select the airbrush tool, then again the state will change. That is airbrush drawing. Okay, airbrush. The cursor will also look like this. Airbrush cursor. Okay, so that is called as the airbrush. About this particular means it changes the state. So this is state testing. Okay, so this is about the end of your the second unit. So that is methods of testing. Okay, methods of various methods of the testing. So in the next class we'll discuss about the levels of testing.